technology of the smallest kind.
It's everywhere. It's in the finest grains of society.
From autos to manufacturing to data centers to communications, everything depends on semiconductors. Semiconductors are more important than oil.
Microprocessors are a highly strategic industry. Across from China, the island of Taiwan is the world's largest producer of electronic chips, a situation that is creating geopolitical tensions.
台湾是中国，台湾更是被外族侵占。If we imagine China taking over Taiwan's semiconductor industry, the worldwide economic shutdown. Taiwan with semiconductor is probably the best defense, has a silicon shield.
Since the 1980s, the United States and Europe have been off-shipping the production of electronic chips.
The globalization trend was driven by differentials in labor costs. It was simply cheaper to hire workers.
Aware of their dependence, Americans and Europeans are facing a race against time to produce their own chips.
They're building the biggest plant they've ever built in the world here in Arizona. 18 months ago, it was desert.
The country that produces microprocessors will thus control the global industry.
The world's geopolitics has been defined by where the oil reserves are for the last 5 decades. And I think where the chips come from is more important for the next 5 decades.
First chips were invented by engineers working at Texas Instruments and a company called Fairchild Semiconductor in Silicon Valley. The first engineers realized that you could take multiple transistors and make them on a single piece of semiconductor material. And so that was the first chip, a piece of material with multiple transistors carved into it.
This single silicon crystal will be trimmed, then sliced and diced. The objective? Semiconductors. Patterns are made by a photographic process and then micro-machined by chemical etching to produce nearly 1,700 transistors on each slice.
And so the jungle of connections was replaced by a single block of material, which was much more reliable and also much more easy to shrink in its size. Law of nature, it's not a law of physics, it's really a law of economics. Moore's law predicts that the number of transistors per chip and as a result the computing power per chip will double every couple of years. And that's been empirically true since the 1960s. If you're able to find a way to shrink your transistors smaller, you will be able to find a larger market as well. And that has incentivized huge investments in shrinking, in improving manufacturing processes, and making chemicals more purified, which means that the capabilities of chips have gotten vastly better and continue to get much, much better at a faster rate than anything else. So I like to think, for example, of airplanes to illustrate the difference. If airplanes doubled in speed every 2 years from the 1960s up to the present, we'd be flying faster, literally, than the speed of light. But chips have done that. Chips have increased in that capability because the scale of the transistors has shrunk. Chips today are measured in nanometers. And so that makes them only slightly larger than atoms, far smaller than bacteria, smaller than a mitochondria, half the size for the most cutting-edge transistors of a coronavirus. There's basically nothing we manufacture at such tiny scale.
The chip war has been declared.
There are a couple of different wars going on simultaneously. There's wars between companies struggling for market share, but there's also competition between nations for who gets which part of the supply chain.
On the 2nd of August 2022, Taiwanese television channels broadcasted the arrival of an official airplane live on air. Nancy Pelosi was on board, the then Speaker of the United States House of Representatives and third in line to the presidency. It's the first time in 25 years that such an important American political leader has set foot on Taiwanese soil.
Today, our delegation came to Taiwan to make unequivocally clear we will not abandon our commitment to Taiwan, and we are proud of our enduring friendship.
Although Nancy Pelosi broadcasts her visit across social media, she doesn't mention anything about a very important meeting about microprocessors. Here she is with Morris Chang, founder of TSMC, and Mark Liu, the current CEO of the company.
These chips, which are at the center of the AI ecosystem right now, are pretty general purpose in their capabilities. They can train many different types of models and are useful both for training and also for deployment. But if you design a chip for a specific type of model or a specific type of deployment, you can make it perfectly optimized for that use case. And so a lot of startups right now are looking at individual workloads or individual deployment opportunities and saying, we're going to design a chip that's perfectly tweaked for that use case. This is startups tackling this industry, but it's also big tech companies, Facebook, Microsoft, Google. They're all designing their own in-house chips as well because they know the specific workloads that are inside their data centers. And they've realized if they design chips specifically around those workloads, they can operate more efficiently in many cases than a general purpose AI chip like NVIDIA's can do, which I think is going to be really important in making AI cheap enough and therefore prolific enough to make a major impact on the economy. When I look at the surge of investment in AI chips right now, I see no reason to doubt that Moore's Law won't continue for a very long time. That means more advanced chips, which means more computing power that we can apply to all sorts of uses, AI and all sorts of devices. And that means we'll be using even more semiconductors because the trend has been that as chips get better, they get cheaper and we put them in more and more types of uses. Today, if your car has 1,000 chips, I wouldn't be surprised if it has 10x that number in a decade. And that basic trend is true of everything we rely on.
In less than 40 years, TSMC has built an empire of mega factories across Taiwan. In the suburbs of Taipei, the TSMC factories are impenetrable. Corporate communication is strict. Interviews with employees are forbidden, as are images from inside. TSMC has become the center of global attention. The company has the power to paralyze the world.
TSMC produces 90% of the most advanced processor chips. From Apple, whether it's an iPhone, or NVIDIA, which powers many data centers, TSMC produces many of their chips. And without TSMC's production, the entire digital economy would simply ground to a halt.
Of all of the companies you know in the world, this is the only company that currently has something they make in our possession right now. There are no others. So there's basically Air and TSMC.
TSMC's stock market value constitutes over half of Taiwan's national wealth. These days, 30% of the world's electronic chips are manufactured on the island. China, the USA, and Europe are lagging far behind and have to import the bulk of their microprocessors.
Decades, India relied on imported semiconductors for space missions, but that is changing now. IIT Madras and ISRO have developed IRIS, India's first RISC-V based microprocessor for space applications. This made in India chip was designed, fabricated, packaged, and booted entirely within the country. Built on the Shakti processor baseline, it's a breakthrough in India's self-reliance in semiconductor tech, building its own semiconductor ecosystem. How was IRIS built, but? Let us tell you. It was designed and tested at IIT Madras, fabricated at SCL Chandigarh, India's premier semiconductor lab, was packaged by Tata Advanced Systems in Karnataka. The motherboard development happened in PCB Power in Gujarat and was assembled by Sarma SGS in Chennai, which means, in the truest sense, Atmanirbhar Bharat. This is India's first fully in-house semiconductor project for space applications. And all of this is just the beginning. While ISRO is building space-grade chips, India's commercial semiconductor industry is also taking off. Union Minister Ashwini Vaishnav just announced that India's first commercial semiconductor chip, developed by Tata Electronics, will be launched by September or October 2025. The chip will be produced at India's first semiconductor lab in Dholera, Gujarat, in partnership with Power Chip Semiconductor Manufacturing Corporation, PSMC. This is part of Semicon India, a 76,000 crore INR initiative to establish India's semiconductor and display ecosystem. To power India's AI revolution, the government is launching the India AI Mission Portal soon, providing 14,000 GPUs for compute access. 10,000 GPUs are already secured from major players like Yotta Data Service, Tata Communications, AWS, and E2E Networks.